Hey guys, Mr. Kyle, Myers Mathematics, and let's just jump right into it. So we're going to talk today about the trick to trig, and yes, it is alliteration that was meant on purpose. Sorry, not sorry. Like a good Baptist, State Farm was always there. Anyways, what we're going to do is we're going to talk about trig, and when I say trig, I mean, of course, trigonometry, right? So trigonometry, right? Trigonometry. And then also all the classes that are around trigonometry. So trig as a class happens roughly between algebra 2 and pre-calc or calc. Um, so like on the whole, it's its own class, but you learn trigonometry as early as usually geometry. Okay, and then you have algebra 2, and then or you could have MCR, algebra 2, math analysis, stuff like that. And then at some point you take trigonometry or pre-calc, which has trig in it. Trigonometry or pre-calc, whatever. And then you go on to move to the calculus, you know. And I put plus because there's more than one calculus. There's calc 1, 2, and 3. If you didn't know that, that's a thing. There's a calculus 3. It's out there. It's actually really fun. I really liked it. So if you're in any of these classes, this video will be helpful to you. Okay, so let's talk about the elephant in the room first. And its name is SOHCAHTOA. All right, SOHCAHTOA. All right, which of course stands for some old horse caught another horse taking oats away, because obviously that's what that stands for. No, it stands for the three trig formulas, and of course there's more than three, but the three sort of foundational trig formulas, if you will, are sine of theta equals opposite over hypotenuse, cosine of theta, see if I left myself enough room, I did, adjacent over hypotenuse, and tangent of theta equals opposite over adjacent. Right? Three foundational trig formulas. Now, SOHCAHTOA is usually completely pointless. Yeah, it's pointless. Why? Because it's given to you. The sine, cosine, and tangent formulas are gonna be given to you. So if you're taking geometry right now, public school, they're given to you as of the time that this video is given out. They're on the exam. Sine, cosine, tangent, they're there. You don't need to remember SOHCAHTOA. You don't need to remember the acronym or the fun sentences you can make from those letters or any of that stuff. All the equations are given to you. So there's no point in memorizing things that are already going to be on the exam for you, in my opinion. Now, if you're not in geometry, or if you're taking geometry in private school or homeschool or whatever, just check with what your exams are allowing you to have for formula sheets. Check your formula sheet guide for the upcoming test or exam or whatever, and see what formulas you can have on there, just to be safe. Because if you do need to remember it, you do need to remember it. But it's a pretty easy formula to remember, nonetheless. So it's not too difficult if you have to. Now, anyways, let's talk about what the O, A, and H mean, and the theta, right? So the little pokeball looking thing. Let's talk about what all of those are real quick. All right, just in case nobody has explained that just yet. So if I have a triangle, let's draw a little triangle here. So if I have a triangle, and I'm going to use the green, red, and blue again, but for O, A, and H this time. And I'll use black for the theta. All right, so here's theta, which, by the way, is a Greek letter. It's a lowercase Greek letter. And so basically, just a little bit of a language / history lesson, I guess. In Greek, there's actually 24 letters of the Greek alphabet versus our 26, and they're both sort of, I mean, they're not both Latin based, but they share a lot of the same characters. Like there's 24 Greek letters, but they're basically all letters of the alphabet. So theta is one of the slight exceptions. It's sort of like if you were to take the word the and turn it into a letter. It essentially is a th sound. Is what that Greek letter theta is. It's theta is how you spell it. But it's sort of like the x, right? When you solve for x, missing side, solve for x in an algebra equation. This is solving for x, but now it's theta because it's different from x because now it's an angle, right? So that sounded kind of confusing, and I'm sorry if it was, but theta is basically x for angles, okay? So let me write that. Theta is x for angles. Okay, so that's all it means. It doesn't mean anything super fancy. It's just x. All right, it's just another way to write x. X is, it can be any letter, right? X can be a, it can be b, it can be c, it can be theta. So in this case, it's theta. All right. So let's talk about the OA and H real quick. So let's use O. We'll use O for this. Actually, no. I want to do H first. So this kind of brings me to my next point, is that there's a right way, there's a correct order per se to labeling the three sides. You want to label the H first because the H is always the slanted side. Okay, if it's not a slanted triangle, like for instance, if your triangle is like like that, and the right angle is like right there, then just kind of flip it around so that it's, you know, right side up. Okay, as if it's like sitting on a desk, you know, sit it flat on a desk, with the right angle on the bottom. So like obviously it's kind of still, you know, the bottom is still the bottom on that version, but make it so that like the right angle is like sitting down. You know what I mean? So like the floor is here, and then it's like kind of like that. If you make your triangle sit flat, so that it has one slanted side, right? One slanted side. If you make your right triangle sit flat with one slanted side, that slanted side will always be the hypotenuse. Okay, so 9 times out of 10, when you see a triangle, it's already going to look like this. So it's already going to have the base on the bottom, and it's going to have the height going up and down. Okay, so you normally don't have to worry about it. If it's tilted in any way, just redraw it so that there's only one slanted side, right? And that slanted side will be the hypotenuse. Okay, so start with H. So start with H. And then you do A next. So you do A next because theta has two sides that make up that theta, right? So every angle, this is another thing you learn in geometry, every angle is made up of two rays with a common endpoint. It's like the technical definition. But if you look here, you've got a side of this triangle right here. That's your H. The only other side that's next to, which is what adjacent means to be next to, the only other side that's next to the theta is the A. So if you do theta first, if you do hypotenuse first, right, hypotenuse being the longest side, then the only other side that's left, that's next to your angle, is your A, right? Oh, and I forgot to spell then. I spelled the. Goodness gracious. All right, so H, then A, then O. Oh, no, I just want blue. There we go. Then O. Okay, so O is the leftover side. O means opposite, so it's just the side that's across, but across starts with A, so it's a little confusing. So it's just easier if you do H, then A, then O, right? And the way you remember it is hey-o. Like when you're saying hi to somebody. Hey-o. Or like that one song that's like, hey-o, hey-o, daylight come and we want to go home. Like that one. I don't know how it goes. It's something like that, I think. I don't know. I don't listen to music like that. I usually listen to like rap and rock and stuff, but all like Christian versions. Shout out to Lecrae. Anyways, so theta is the x for angles. You got H, then A, then O, which spells hey-o. All right, so heyo, remember heyo. And now let's get into the 3 steps. So there is a 3-step process for solving any triangle ever. This is the trick, right? 3-step process. There we go. Okay. So the one thing to keep in mind actually, and I'll make this like a step 0, right? So step 0 is you need a right triangle. Right triangle, right? It has to be a right triangle. And you have to have you and you have to have, okay, right triangle, and you have to have 2, that is not a W, 2 bits of info. Okay, so here's what I mean. You have to have a side plus an angle, right? So these are like quasi formulas here. A side plus an angle will give you the other side. Or if you have 2 sides, then you can solve for an angle. Okay, so if you have the theta and an A, an O, or an H, then you can solve for one of the other sides, the A or the O or the H. If you have 2 sides, an A and O and H, or an H and A, you can solve for theta. Or the 3rd side, if you really wanted to, but you wouldn't use trig for that, you just use Pythagorean theorem. So that's another topic for another time. But you know, it's a pretty easy formula, a squared plus b squared equals c squared. So step 1, let's get into the meat here. And actually we're kind of coming to the last bit of this video, because really this is it right here. This is like the meat. This is what's going to help you the most right here. So step 1, this is what you do. This would be really important to write down or take note of if you're in this class. Label the sides. Okay? And then of course what I mean by that is you label them, you know, heyo, right? Hey, h, a, o. Right? You do your heyo. Right? So step 1 is heyo, right? So I'm going to do an example triangle as I'm talking about this here. So my example triangle, here's my theta, here's my angle. All right, so you label your sides. So actually, let me do an actual example with like real numbers here, and I'll actually solve it and everything here. So let's do 33 degrees, and let's say over here is x. We want to solve for x, and this is 5 right here, and I don't know what this bottom side is. So label the sides first. Heyo. So the slanted side, right? It's upright. It's sitting upright. There's only one slanted side, so that slanted side is the H. Boom. Okay. And then adjacent, next to, it's the only other side that's next to the angle, so that's A. And then O is the one left over, so that's O. Okay. So label the sides. Check. Done. We're 1/3 of the way done. Number 2. You pick the trig equation. Pick the trig equation, right? Meaning sine, cosine, or tangent. And again, I'll use green here. So sine, cosine, or tangent. Okay? So we're going to pick sine, cosine, or tangent here. Now, the way to figure out really easily which one you need is eliminate the letter that doesn't have something next to it, right? So we don't want to find A because there's nothing next to it, so we get rid of A. What's left? O and H. Well, the thing that has O and H is going to be sine. So I'm going to do sine. And for sine, what I'm going to do to differentiate my colors here is I'm going to underline sine here. So I'm going to underline it. Okay, so here we go. So sine of theta, which is 33, so I'm going to use 33 degrees, equals O, which is x, over h, which is 5. All right, so there we go. So O is x, h is 5, and it's the sine of 33. Don't forget sine of the angle. It's not just sine. You can't put sine next to it. It was just no number attached to it. It's just, that wouldn't make any sense. It would be like saying the square root of, and then not saying a number next. Okay, so I want you to equate those two things. Like when you see a square root symbol and there's nothing under it, that looks weird. There's nothing happening there. So it's the same thing when you do sine, cosine, or tangent and you don't put a number next to it. If you say sine equals, that doesn't mean anything. It's just it's like if you say times by, like what? Times by what? Like what are the numbers? Right? So I want you to equate those things. Like if you see sine, it should have something attached to it, whether it be a number or a letter. Okay, so that's my spiel on that. And then, so we're basically done now. We've only got one more step, right? So 3-step process. We're on step 3 here. Step 3, you solve it. Step 3, solve it. Okay? And if you are solving for a missing side, you're always going to multiply by whatever the bottom number is, aka the denominator, in order to solve for x or whatever your letter is that you're solving for. Okay. Now, if you're solving for a degree mark, if you're or not the degree mark, goodness, if you're solving for theta, if you don't know what the angle is, but you know what the two sides are, then you'll just take the inverse sine or cosine or tangent or whatever. But here's what's up. Okay, so there's only 3 different ways to do this. Either one. Let me say it like this. If you want to solve it really easily, you need to keep something in mind here. It shouldn't take more than 2 steps. Okay? If you're trying to solve this equation, our example is sine 33 equals x over 5. If you're trying to solve that equation and you're on step 3 of trying to solve it, you're definitely doing something wrong. It doesn't take more than 2 steps to solve any of these. Okay? So the most it'll take is 2. And actually, it oftentimes only takes 1 step. And you'll see that right here. Look. So all I need to do is I multiply by 5, multiply by 5. 5's go away, and x equals 5 sine 33. Boom. All right. So if they want a quote exact answer, you can actually just stop there, because that's an exact answer. Once you type it into a calculator, it approximates, so it's no longer exact. All right, technically. So let me see what I've got here. 30 sine, oh no, and radian mode, degree mode. Okay. So I want sine 33, which is about a half, and then I want to times that by 5. So times it by 5. And I'm going to round to 2 decimal places because that's pretty standard for a math class. 2.72 is what I get. All right. So 2.72 is x. What does that mean? That means that's the length of x. Okay. So the hypotenuse has a length of 5. X has a length of about 2.72. And we're done. Okay. That's it. Now, I mentioned earlier about solving for an angle. Let me show you one more example where you're solving for an angle. It's just a little bit different, and it's actually easier to solve, but it's a little weird because you have to do something that's maybe a little new to you if you're taking this for the first time in geometry. Okay, so let's have theta, and let's say this side is 4 and this side is 3. Okay. Now, we don't care what the third side is. It would be 5, if you were wondering, because Pythagorean triples. But we don't care what the other side is. Okay, we just want to solve for theta. Now, here's what you do. You still do the 3 steps. Okay, so let's recap. Step 1, label the sides. Okay, heyo H, okay, A, and O. Okay, heyo. So then, step 2, we're going to eliminate the one that we don't need, right? The thing that doesn't have a letter or a number next to it, so that we can pick the trig, okay? Pick the trig equation, sine, cosine, tangent. We're using A and O, so that means we're going to be using tangent. Tangent, don't forget, tangent goes with something, either a letter or a number, all the time. Tangent theta equals opposite 4 over adjacent 3. Okay, now, normally what you do when you have a denominator is you multiply by it so it goes away. But in this case, we're not going to do that. We're going to leave it alone. What you have to do to solve for theta is you have to get rid of tangent, okay? But tangent is not being multiplied by theta, okay? Let me repeat that. Tangent is not being multiplied by theta, okay? Tangent doesn't exist on its own, just like a square root sign doesn't exist on its own, okay? It's the square root of something, so you'd have to do the square. It's the opposite of a square root, right? The opposite of a square root is a square. The opposite of a tangent is what's called an arctangent or a tangent inverse, okay? So it can look like one of two things. I'm going to draw both. So it could be the tangent inverse of the tangent of theta and look something like that, right? Tangent inverse of 4/3. Or it could look like this, arctan. In your calculator, some calculators will say arc. So arctan of the tangent of theta equals arctan of 4/3. Okay? So it can look like either of these things. Tangent with a little -1 power looking thing, which means tan inverse, or arctan, which is just spelled out ARCTAN. Okay? Both of those mean the exact same thing, and some calculators have one or the other or both. Usually you can access them by hitting second on a calculator. Now I'm using my phone calculator, and I have an iPhone 7. It's an older iPhone. But when I hit second on my phone, it shows me inverse. So it has little powers. All right, and that's what you want to do, is you want to do the powers, okay? So when I do the arctan of the tan, those are opposites, just like timesing by 2 and then dividing by 2 is like the opposite, or adding 2 and then subtracting 2. Arctan tan, it goes away. It cancels it because they're opposites. That's how you get rid of it. I know it's really weird if you've just been seeing this for the first time, but it's just like when you do the opposite of add, subtract, multiply, divide, and like powers and roots, okay? It's just another kind of math thing you can do, basically. So it has an opposite. Every math thing you can do has an opposite. And for tangent, it's tangent inverse. For sine, it's sine inverse. For cosine, it's cosine inverse. It's whatever the thing is with a little -1 thing. Okay, so all we need to do now is just type in tangent inverse of 4/3. Now, since I'm using an iPhone calculator, it's kind of backwards. So I actually have to type in the 4/3 first, and then hit second, and then hit tan inverse to find out what that is. So it is approximately, and again, I'll round to 2 decimal places here, 53.13 is my final answer. Okay, so that's another example. One, because I wanted to show you how to solve for theta, and two, because I wanted to show you one more example at least on how this method works. All right, so this is the trick to trig. This is what I wanted to show you. This is helpful for geometry, trigonometry, calculus, everything in between. I hope this video was helpful. If it was, give it a like. If you want to see more videos like this, go ahead and subscribe to my channel, Myers Mathematics. It's the one with the fancy M, not that other one. There's some other guy out there, I don't know, they stopped making videos a while back or something, but it's like also called Myers Mathematics. But you know what? They don't have a website. I do. So you should go check it out on my website as well, myersmathematics.com. And of course, so I'm like super close, should have this by the end of the week for sure, like trying to make sure I get this by like tomorrow. But what I'm trying to do is automate the process to deliver an amazing free guide to you guys. Just automatically deposits it in your email mailbox when you go to the website and you ask for it, okay? It's called The 5 Math Mistakes Everyone Makes and How to Avoid Them. It's basically just a free PDF guide that you can throw in your pocket and just have with you wherever you go. And what you do is you can kind of just take it and read it, and then you can kind of just jot down like the 5 things. So there's 5 things, and they each have pretty simple solutions, but then I kind of like explain what it means for that solution to work in like a few paragraphs and examples and stuff. But every math mistake that I've noticed boils down to 5 things, and I've narrowed it down to those 5 things and put them in a guide so that you can watch out for those 5 things and make sure that you don't make any more math mistakes, right? And yeah, it's easier said than done because math mistakes happen all the time. But you'll know like, hey, I'm missing this problem because of this, and you'll be able to tackle it a lot easier and get on track for your math, and it's just great. You should go grab it. I worked on it like a lot, thinking about how to word everything and examples to put in there and stuff. So go check it out. Go grab that free guide. It's on my website, myersmathematics.com, and it'll be auto delivered starting like no later than by the end of this week. All right. Yeah, and as always, this is Mr. Kyle at Myers Mathematics. Ciao.